Welcome to the second lecture in Module 10. In the first lecture, I discussed measures of association for continuous variables, and we focused on correlation. In this lecture, I'm going to discuss measures of association for categorical variables, and we're going to focus on odds ratios. And so, in talking about odds ratios, we need to talk about the 2x2 contingency table. And you've seen the contingency table previously in our lecture on probability theory. And so epidemiologists love these 2x2 tables. And these 2x2 tables typically list an exposure and an outcome. And so the exposure is usually listed in the table in the rows, and the outcome usually defines the columns. And so in the table there, it's often listed this way, with A being both exposed and experiencing the outcome, B being both exposed and not experiencing the outcome, C being not exposed but experiencing the outcome, and D being not exposed and not experiencing the outcome. And so that's how the table is going to look throughout this lecture. And so it's important to think about what the table means. And almost always the outcome in these tables is defined so that yes is considered bad or undesirable. For instance, the outcome might be death or instead of survival, or loss instead of profit. So usually the outcome is considered bad, and almost always the exposure is to a harmful thing, such as exposure to smoking or exposure to a chemical. And so what we're trying to find out here, we're looking to see if an exposure is a risk factor for experiencing the outcome. Does being exposed make you more likely to have the bad outcome? Or possibly maybe the exposure is protective. Does being exposed make you less likely to have the bad outcome? And so in order to determine that, we calculate the odds ratio. And the odds ratio for the exposure related to the outcome is the equivalent of A divided by C, so cell A divided by cell C in that table below, and that's in the numerator, then divided by cell B divided by cell D in the denominator. Another way of saying it is we multiply cell A by cell D, and then divide it by cell B multiplied by cell C. And so just follow the formula up there, and that's how you calculate the odds ratio. So what does the odds ratio mean? It's easy enough to give the formula, right? So odds are the number of outcomes relative to, in other words, divided by the number of trials. And so consider 10 coin flips where you had 5 heads as the outcome. You could calculate the odds as a 5 in 10 chance of getting a heads, or 0.50. So that's the odds. The odds ratio is a measure of association between an exposure and an outcome. And so there's a ratio involved. It's the odds of the outcome happening in the exposed group relative to the odds of the outcome happening in the not exposed group. And so literally, we're taking the ratio of the odds of the outcome in the exposed group divided by the odds of the outcome in the unexposed group. And so that we can walk from the English here into the math, let's take a look at the formula again that I presented a couple slides ago. So we have in the numerator the odds of the outcome among the exposed divided by, in the denominator, the odds of outcome among the unexposed. The odds of the outcome in the exposed is cell A divided by cell B, right? Because both of those have been exposed. You have exposed and outcome divided by exposed and not outcome. So that's in the numerator. The odds of the outcome among the unexposed, which is in the denominator, is cell C divided by cell D. And so if you do the algebra, flip the equation around, you can see that that is the same thing as cell A multiplied by cell D divided by cell B multiplied by cell C. Okay, so let's look at an example here, and hopefully that will help make it clear. We're looking here at comparable general hospitals in 2013 from the California hospital data. Here we're going to call the exposure being in a rural area. So the exposure is rural status, and the outcome is that the hospital is unprofitable. And so we have unprofitable and profitable. And unprofitable is the outcome we're going to construct the odds ratio for. So the odds ratio for rural status as a risk factor for unprofitability is 25 multiplied by 171, so that's A multiplied by D, and then divided by 34 multiplied by 75, that's B multiplied by C, and we get an odds ratio of 1.68. So rural status is a risk factor. You can take that to mean rural hospitals are 1.68 times more likely to be unprofitable than non-rural hospitals. Let's take a second example. Again, we're looking here at comparable general hospitals in 2013. And here we're looking at the same outcome, unprofitable or profitable, but here the exposure is not-for-profit status. And so you can see the numbers in the table there. So the odds ratio for not-for-profit status as a risk factor for unprofitability would be, again, we have cell A multiplied by cell D, that's 51 multiplied by 56, divided by cell B multiplied by cell C, 115 multiplied by 24, and our results show odds ratio of 0.97. And so the way you interpret an odds ratio less than 1 is that the exposure is protective. So here, not-for-profit hospitals are 3% less likely to be unprofitable than for-profit hospitals. So we can also, you think about odds ratios in terms of the chi-square test. And so let's think about these two things here, because you can do both with the contingency table, right? So the odds ratios are measures of association. If there's no association between these two characteristics of interest that we're looking at, the value of the odds ratio is going to be 1, just 1.0, as long as we're setting up the 2x2 table in the usual way that I've done in this lecture. And so a value greater than 1 indicates a risk factor. The exposure is a risk factor, but a value less than 1, like we saw for not-for-profit status, indicates that the exposure is actually a protective factor. In either case, the further away from 1 that the value of the odds ratio is, the stronger the association. So the chi-square test, on the other hand, is a statistical test of association that's used for hypothesis testing. And so the null hypothesis is that the two variables are independent. Interestingly, in a 2x2 table, if we're interested in statistical significance at an alpha value of 0.05, the critical value of chi-squared, if you look it up in the table in your textbook, is 3.84. So values of chi-squared greater than 3.84 using the formula that we looked at in the previous lecture to calculate chi-squared, any value greater than that would lead you to reject the null hypothesis and conclude that the two variables are associated or not independent. So, an important caution here. 2x2 tables are set up as if they're looking at causation, right? It looks like one variable, the exposure, causes the outcome. But really, this is not causation. They're just measuring an association between two categorical variables. There are all kinds of other missing variables that could be confounding the relationship between those two variables in the 2x2 contingency table. Right? So remember, a high odds ratio or even a significant chi-square test doesn't prove that the exposure causes the outcome if the only thing we're looking at are those two variables. Just an important thing to keep in the back of your mind. Okay, that being said, we can create both odds ratios and do a chi-square test using a 2x2 table. And so just because the odds ratio is positive does not mean that you can reject the null hypothesis that these two variables are independent or not associated, right? So I'm going to walk you through an example here. And the question is, can we reject the null hypothesis that rural location and profitability are independent? So I put the table back up on the slide here, and I've also calculated the total around the margins because we need those to calculate the chi-square test. So the odds ratio, as we previously saw for rural status, is 1.68. So, living in a rural status makes you a lot more, the hospital being in a rural area makes it a lot more likely to be unprofitable. But our null hypothesis is that these two variables are not related at all. And to test that, you don't use the odds ratio, you use the chi-square test. And so we went over this in a prior lecture, but you can see I have the formula for the chi-square test there, right? You're taking the observed minus the expected value squared for each cell and dividing it by the expected value for each of the 4 cells in the table. Remember, you calculate the expected value for each cell as the product of the row total and the column total divided by the overall n table total in the lower right-hand corner there. So you do that for each cell. You take the square of the observed minus the expected divided by the expected, and here we get a chi-square statistic of 3.1. However, 3.1 is less than the critical value of 3.84 in the chi-square table, right? If we want to set our significance level at alpha equal to 0.05. So what that means is because 3.1 is less than that critical value, we can't reject the null hypothesis. Although our odds ratio suggests that rural status is a risk factor, when we do the chi-square analysis, it shows that the difference in profitability by rural status are not large enough so that we could rule out that they happen by random chance. So we would conclude that they're actually independent and doesn't look like there's an association.